Ikutia. I am Alina. Today, we are going on a fun adventure into electromagnetic induction. That is a big phrase, but it means this. When magnets and wires move, electricity can appear like magic. We will keep swapping pictures, often so it feels like a colorful storybook. Ready? Let's go. Imagine making electricity just by moving a magnet. It powers bike lights, giant power stations, and even helps hospital machines see inside our bodies. Here is our plan for today. We will learn 5 friendly ideas. 1. Magnetic fields, the invisible push around a magnet. 2. Moving magnets and wires. 3. Faraday's law, which says changing magnet stuff makes a voltage push. 4. Lenz's law, the rule that the push fights the change. 5. Simple generators, like a tiny hand crank light. Let's check the list together, one by one. First, magnetic fields. Think of them like invisible lines that leave the north side and loop around to the south side. When we draw them, we see smooth curves going from N to S. The closer the lines, the stronger the magnetic field. Now, moving magnets and wires. If we move a magnet closer to a loop of wire, the magnetic field through the loop changes. That change makes a tiny push on charges. We call that an induced current. Watch the arrow on the loop. It is the current that appears because we move the magnet. Time for Faraday's law. We can say it like this. Changing magnetic flow through a loop makes a voltage push. In math words, epsilon equals negative d phi sub b dt. Phi sub b means magnetic field times area times cosine theta. If that changes with time, a push appears. The faster the change, the bigger the push. Lenz's law time. The new current always pushes back against the change that made it. If a magnet moves in, the loop's current makes its own magnet that says, hey, slow down. Look, the motion arrow shows the magnet moving in. The green loop arrow shows the current that tries to oppose that change. Let's build a tiny pretend generator. A loop spins between a north pole and a south pole. As it spins, the magnetic flow through the loop changes again and again. That makes a push that wiggles up and down like a wave. And that is how a hand crank light or a big power plant makes electricity. Everyday things use induction. Bicycle dynamos light your way at night. Transformers in chargers change high voltage into low voltage for your tablet. Motors in toy cars spin the wheels. See these cute icons to remember: bike light, charger, and toy car motor. Quick recap, cutie. 1. Magnets make fields. 2. Moving magnets and loops change the magnetic flow. 3. Faraday says change makes a voltage push. 4. Lenz says the push fights the change. 5. This is how generators, chargers, and motors work in real life. You did amazing. High five.